Hello, this is Mike at Gamefromscratch, and welcome back to our LibGDX tutorial series. Today we are looking at Scene2D still, specifically at two different elements. The first one is going to be grouping. The second one is going to be hit testing. Grouping is a pretty straightforward concept. Up till now, when we looked at Stage 2D, you may recall your stage itself, Scene2D, you may recall that your stage is where all your game entities are stored. In other game engines, this is often called the scene graph, and then all your nodes that make up your game are actors within that. However, a lot of times you're going to want to group things logically together, and one of the things that's a little misleading about a stage is you think about it in terms of the real world, where the stage is this visible space. But that's kind of inaccurate. A stage can be as big as you like, and the amount of size of it, like literal physical size, X and Y width, is meaningless. It's just a container to store your world in. So if you thought about a 2D game, like say one of the old Ultimas, your entire world could actually be stored in a stage. A stage is not just, do not mix stages and viewports up. They have nothing to do with each other. However, a stage does have a viewport, and that is what determines the portion that's visible on screen at the time. So I know in the real world analog, a stage is a very finite-sized thing that you look at. In LibGDX, that is not the case. Stage is actually kind of a bad name in a way, because it's just a data container. It's for holding a bunch of actors that you in turn call their act and update functions. We covered this in the past, so I'm not going to reiterate through it. However, when you have this really big container, you're going to have a mess very fast of actors that are very confusing. So then you need to organize them. And the number one way to organize these things is through a thing called a group. A group is an actor that contains other actors, basically. You can inherit from it as you wish, so you could make an entity within your world which is a group, which then contains a number of either other groups or actors, etc. So that's what we're going to be taking a look at today. Just want you to see a couple things before we continue. I'm going to start this very basic application, but I've created and already added these graphics to it. So I've got 2 playing cards and a poker table. I needed something to play with, so I picked these at random. So these are what we're going to work with. I've already set up my project to a certain degree, but I haven't touched any of the code. So first thing I'm going to do is I'm actually going to change the resolution, just so this displays nicely to work with this graphic. This graphic is 1024 by 512, so what I'm going to just do is go into my desktop launcher, and your configurations, once again, are done at the per level. So if you do desktop-specific configurations, such as setting the resolution, which you can't do on a mobile device, you do it in the config setup for each particular project. So in this case, I'm using the desktop launcher, and I would set the resolution here by going config.width equals 1024 and config.height equals 512. Now this is platform specific, so this will actually only impact the desktop build. However, if you want to do the same thing for HTML, you'll find there's a very big consistency here. Just go into the HTML launcher instead, and they get they've structured their code a little bit differently, but the same thing. You could do it right here. You could turn this into multi-line, so you could change your resolution right here, or you could just turn this to create one of these, set the properties on it, and then return it out. Ditto for Android, ditto for iOS. Each one has their local config versions. I think I may have covered this in the past. I'm not entirely certain, but in this case, all I've done is I've created my window to be 1024 by 512, just so it displays nicely with our graphics. All right, so let's go on back to the main code. This is your standard startup project. We're going to be getting rid of 99% of everything that's here. So let's just kick into presentation mode so you can see what I'm doing. All right, let's get started. So first thing, we've already covered scenes, so I'm going to gloss over most of what I'm doing here. I'm just going to create a new scene. So really the only thing we want to keep is that clear. So that's the call that clears the graphics every screen. And we need a variable, which is a stage of that type. We will call it stage. So, and then in our create call, we allocate our stage, equals new stage. Stage requires a viewport. Let's go with a screen viewport. Once again, screen viewport will actually just fit to the resolution. So it'll be, our dimensions will be 1024 by 512. So let's go ahead with that, like so. All right. Now just down here in our render loop, we're going to call the stages act function, which will cause each of the children and their act functions to be updated. We're not actually doing any action, so this is a little superfluous in this example, but let's pass in the delta time so it knows how long it's been since it was last called. And finally, the draw. For every stage related application, you should really do these two. Eventually you are going to need them, so just get in the habit of calling these two each time in the render loop, like I just have. Alright, so I've gone ahead, I've created our stage, set it to the screen's dimensions, called act on it, and then draw. So let's go ahead and run this. There you go. So our widescreen stage is drawn up in black clear color. So now let's go ahead and do something with it. We're going to, first off, we're going to create the group. I'll show you how easy it is to actually create groups. Alright, so we need to add a group. Group equals new group. Alright, Alt-Enter. And it's a LibGDX group. Okay. All that was doing was resolving the import that was called to make sure it was a LibGDX as opposed to an AWT or some other version. Alright, so there we go ahead and create our group. Now what we're going to do is we're going to create 3 images. The first one is going to be the background, and then the 2 are the different playing cards we have. As you may recall, an image is a type of actor. It's inherited from actor. It's an actor that has, well, predictably enough, an image attached to it. So let's go image, and we'll call one, oh, here, Alt-Enter. Oops, it wasn't Alt. Alright, let's try that again. Alt-Enter, and then we're going to pick that guy. Table image equals new image. New texture, and then gdx.files.internal, and I believe I called it table.ping, like so. Once again, very important thing here in this demonstration code to keep it short and simple and so on and so forth. I am not calling dispose on anything, so this code will ultimately leak a texture handle eventually. So obviously if you're going to create something like this, you're going to want to dispose the texture at some point in time because it is a managed resource. Alright, ace image equals new image. Alright, so that is new texture gdx.files.internal, and that is ace.ping, predictably enough. And let's try some copy and paste coding. AU. And then that'll be king and king. Alright, so there we got ahead. We've created our 3 different images. We have our group like so. And now we're just going to go ahead and group.add actor table image like so. And back to the school of cut and paste. Ace image and king image. Now I'm going to stop and point something out kind of important here that you'll see later on. The order that you add things by default is actually quite important because the order they are added is the order they are drawn by default. We'll look at that a little bit later, but if you add the king or the ace before the table, it will actually be drawn behind the table, again by default. So something to be aware of. When adding actors, the Z order is determined by the order they are added. Okay, so there we go. We got a group full of actors of images, and then we simply go stage add actor, and we add our group. Ta-da! Now, in theory, let's do some positioning so that things don't look awful. King image.set position, and we will put this at 300 and 150. And now ace image, and we will put that one at let's say 400. I want them to overlap slightly. Okay, in theory that should be done. Let's go ahead and run that code. There you go. So you've got your stage has a group on it, and that group contains this table and a couple of cards. All right, pretty cool, pretty easy so far. Let's play around with that a little bit more. So next thing up is I'm going to want to have a little bit of control or input over this. So all old hat stuff, I'm just going to create an input processor. We've done this many times, but at this point, for my little light bulb, go ahead and input. Alright, before I forget, gdx.input.set input processor to this. Now let's go down to our key thing, and I want to show you some very neat things about grouping things together, and you'll see why groups are quite valuable in a second. We're going to be using a group quite often in this one, so let's just go ahead and in the key down handler, let's get a reference to our group. So our group is group equals, and we're going to need a cast on this one. This is actually kind of going to show you a bit of how stage works. You can access stage, get actors, and since the group is, well, literally the only root level actor, we can get away with calling first. So there we go. That is getting the first actor that's been attached to the stage, and since the group was the only actor that was attached directly to the stage, we know it's our group. So now that we've got our group, let's go ahead and wire up some code. So if key code equals keys dot, let's go with right first. So if you press the right arrow, okay. If they press right, then what we are going to do is rotate the group. Set rotation to group dot get rotation plus 1 degree. So now let's go down a bit and do a left, and predictably enough, make this a minus. And finally, we actually handled this event, so let's go ahead and say we did. All right, so now we go ahead and run our code, and you'll see a very neat thing about groups. There. So now I press the left or right arrow. Ta-da! See, when you rotate the base or the parent, all of the siblings, in turn, go with it. So that's a very powerful thing about a group. The nice thing is you can turn a group could be a level. And then all of the stuff that makes up the level could be children of the group, or a group could be a helicopter, which in turn was composed of the main body, the rotors, the missiles, and you just kind of string them all together, but then you can manipulate all of them using the group coordinates. So you can move things and change things using the group. And it's not just movements that you can get away with here. Let me just show you something else here. Let's do it with, let's see, the up and down arrow. Oops. So let's do if key code equals input.keys.up. So what we're going to do is take the group and set the color of said group to, and it's going to be a little bit of ugly code, get color.r, get color.g, so that's the red, that's the green, group.get color.blue, and then group.get color.a. Alright, first let's get that across 2 lines so that when I paste it later, it all works out fine. And all we want to do is take this alpha value and say on up, we're going to add +1f. So increase the alpha value by 10%, or in the event of the, predictably enough, down arrow being pressed, we will decrement by 1 instead. So, alright. So, assuming I did not make a mistake here, run, and let's go ahead and just run that. So now if I press the up and down arrows, you will see the entire group fades in and out. So not only can you set the position, rotation, scaling, etc. of the group, you can also set the transparency of it. So it allows you to manipulate things quite quickly as an entire, well, group. Is the exact point of this all. However, what you're going to find, oh, I guess I should pause and do one thing quickly. Remember way back when we implemented our own draw call? We inherited image and then overrode the draw call. Well, one of the things being passed in was the opacity, or the alpha. And I'm not sure if we used it at the time. I believe I commented that if the parent, this is what the parent will pass in. Well, when you're overriding that draw call, if you do not yourself use that value or pass back to super's draw, you will not get this transparency. So you got to make sure that you actually implement this if you override it. Since we're using a built-in sprite class, built-in actor derived class, they've done the work for us. But if you are inheriting your own and you are playing with the color values like we just did, make sure in your draw call that you make use of that alpha value that is being passed in. All you do is you multiply the sprite patch that's being provided, and it will do the work for you, but you do have to implement that. Okay, so I think that was in the previous tutorial. If you kind of confused what I'm talking about, just go back to it, look at the one we inherited, and you should see what I'm talking about. All right, so The next question is when you're dealing with a group, well, what happens if you want to actually update an individual thing within the group? That's a good question. Let me just go ahead and we're going to take a reference to our ace. We will call that image ace. I'm going to show you one thing first, and we're going to come back and show a slightly nicer way of doing this later. We added the ace as the second. You know what? I'm going to change this just to be consistent with the code I wrote earlier. There. So the ace is the third item that we added to our group. And we're going to take advantage of that fact and write some seriously ugly code, but it will show you how to access values in groups using one way. And that is, we're going to image cast just like we did our group cast. Instead of accessing it from the stage like we did here, we're going to access it from our group using get children. So all of the actors that are part of the group are available via the iterator get children. And then we're just going to get the nth one, in this case 2, and that will be our ace card, like so. So that's a way of getting a reference. Again, in real world, you're never going to do hard code this way unless you've got a very simple, trivial scene. So we will look at that in a few seconds. So this is kind of gross. I know that it's gross, so don't worry. We'll come back to it in a minute. So let's go back to our if statement here. So if the right key is pressed, we're doing this. So we're going to do it if the control right key is pressed. We're only going to change the... So, sorry, if the control key is down when the right key is pressed, we're going to only rotate the ace. So let's look at how to do that. That would be if gdx.input.is key pressed keys.control left. So it's left control key only. You'll have to do an and if you want to check for both. Alright, so if the control key is pressed, we want to go ahead and do an ace.set and then ace.get rotation, like so. And then we're going to have to else out this other one. Alright, so if the control key is down, we just do the rotation on the ace alone. Otherwise, we're going to do it on the entire group. Let's go ahead and do this on the left so you can see the logic in reverse. That is if gdx.input.is key pressed, and then input.keys.control left. So then we want to do ace.set rotation, and then ace.get rotation minus 1f. Okay, and we need to else that out. Like so. And let's go ahead and run that. And now left arrow, sorry, that was right arrow, left arrow, and now control right arrow and control left arrow. As you can see, you can implement it. You could work as an entire group, or you can use a single entity within the group. Okay, now let's cover one more thing there. Remember I told you that we're accessing by index, and this is kind of gross? Well, it definitely is. But in a game, you're also going to want to tag something by a name. The problem is we need to actually give things names. So back here, we created our 3 images. Now let's go ahead and actually give them IDs. So image dot, table image dot set name equals, and then we'll call that one table. And we want to do ace image dot set name, and that one will be ace. And then king image, bet you can guess, equals George. Let's go with king. All right. So now they're named as opposed to indexed. Well, they're still indexed, so the existing code will still work. However, let's change this to be something that's a little bit more maintainable. And that's just a matter of going group.find actor. And then you can find that actor using the key you just used. Same logic, much better, much easier to read, much easier to maintain, much less fragile code we just created. And probably technically marginally slower, because obviously you're going to do a string lookup as opposed to just an index lookup. So if you're doing this in a loop a lot of the times or whatever, you're going to want to cache it. However, that should not really be a big concern at the front of your mind most of the time. So now we're going to go ahead and run that. I don't know why I ran it, because it's actually the exact same code. But you'll see if I hold control, see, goes and works. Okay, so there's a very handy thing. You can tag an actor with a name and find it accordingly. Coincidentally, you can also do that with stage. Stage dot get actors dot find. Oops. Dot get root dot find actor. So across it doesn't have to be in a group. It can be across the entire stage by using stage.getRoot and then finding actors, and that will search through your entire world for something with a name. I believe if two things have the same name, it will simply find the first, but don't quote me on that one because I might be making that up. So that's grouping and handling things together. It's very, very, very handy for sure. Now let's quickly move on to hit testing. Let's go back to our world, which means I have to run things here. All right. So here's our game. Now what you're going to commonly want to do is select things in your game. So when I click here, I want it to give me the ace. When I click here in the king, I want it to give me the king. If I click here, I want it to give me the table. How do we do this? Fortunately, it's actually quite simple. Let's go back to our code, and we will do this in our touchdown function over here. The only thing that sucks here, your screen coordinates, we talked about this a little bit earlier, screen coordinates are via the top left corner of the screen, whereas stage coordinates are bottom left of the world. You need to convert between them. Fortunately, that is there. Unfortunately, screen coordinates come in as ints, and everything else in LibGDX is float. So you have to do a somewhat annoying casts. I kind of wish these were floats. I get why they're not. You can't have something be 1.3 pixels down. There is no value there, but it would be more convenient if they weren't ints. Another thing to be aware of here, I'm doing this code to be terse. This is very bad, what I'm about to do. I'm creating a new vector. Actually, I'm creating two in a minute. Every single time the user touches down. There's no problem with that. Like, it's not... it's a garbage collected language. It will be eventually all of those vectors I create. So if you touch down like 1,000 times, you just created 2,000 vectors when you run this code. In a game, you're not wanting to trigger the garbage collector. So what you would probably want to do is actually create like a vector2 called temp, or something that is part of your class, your stage, your entity, however level you can scope it down to, but keep a temp variable that you will reuse over and over and over again. That way, instead of having 2,000 or 3,000 like number of touches times 2 of these vectors being created, then you only have 2, and that's key. So what I'm doing is just to make the code readable and easy to understand. But when it comes to implementing your own, cache these values, make your own little temporary variables, and reuse the heck out of them. If you go through the libGDX code, you'll find that they've done this over and over and over again. All right, so what you got to do is first off, you got to take these x and y coordinates that are passed in that are via the top left corner, and we have to convert them into stage coordinates. And I bet you can guess by the code completion how we're going to go ahead and do that. And that's screen to stage coordinates right there. And we need to pass in a vector2. Here's that second one we're creating. And we need to do a cast. So screen x and screen y, like so. So that will return out a vector2 that contains the coordinates in our stage world where the user touched. So that takes into account if you've panned, if you've rotated, if you've moved, whatever. Sorry, rotated was the wrong thing to say. But if you've moved around in your world, this will take that logic into account. So now we've got a coordinate in. Let me see, turn that in. So we now have a coordinate in. Okay, what are you upset about? New vector2. No vector2. Try that again. Now we have the coordinates in our stage coordinate. Now what we have to do is test in our world to see if there's anything at that location. And this is using something called a hit ray. A hit ray can be thought of as a beam in space that goes straight out from that x and y coordination and into your world. This is where Z orders start becoming very important, and it's just going to go until it hits something. The very first top level thing it hits is going to be what's returned. So now actually to do this hit test, we simply go actor, this is going to be the result, and then hit actor equals, and then stage, and then we do hit. We pass in our coordinates x and coordinate y, and next up is a true or false. Now every actor has a property called touchable. If you want to make something that it can't be touched, you pass it in as touchable. You say touchable equals false and it can't be touched. This is saying to override that or not. So I'm going to say, it doesn't really matter what I'm going to say here, but I'm going to go ahead with false. So saying we don't give a damn. So test regardless and give me all the results. If you only wanted to test for the touchable stuff, you would pass in true in that particular case. So now that did a hit. It threw a ray into the world and it returned a reference to the actor that was hit first. This is important because we have the two different cards that are overlapping, right? And we'll see that in a second. So we'll do a if hit actor not equals null, because it will be null if nothing was hit. And we'll go gdx.app.log hit. And since we have the name, we'll just go ahead and do hit actor, and we'll get the name of the returned actor. All right, so this is going to turn a reference back to the actor that was hit, and in which case we're just going to print out its name in the app log. And I should actually set this to true to say that we've handled this event. Now let's go ahead and run this code. Okay, so now when I click, all right, 1 second, I need to turn, oh, there we go. So when I click, you see it hits the table. I click the king, it hits the king, it hit the ace, it returns the ace. Now let's look when I'm overlapping, and I'm going to predictably enough get ace. Okay, once again, that is determined by the Z order, and the Z order by default was set when we did the ordering. So this was the background here was the first item we had, the king was the second, and then the ace was the third. So the ace's Z order is the highest up. You sometimes, however, are going to want to actually control this yourself, especially if you don't know specifically the order things are loaded, but you do know the order something should be added, then you will set the Z yourself. And let's go ahead and set that. We'll go back to our key handle. We'll add it in code here. So we already have a reference to our ace. Let's play around the ace. And what we'll do is, if they press the number key, the 1 key, so if key code equals keys dot, I think num, yeah, number 1, like so. And all we're going to do is take the ace, and we're going to set its Z order. Z on index. Okay, so we'll just take what its current index is, get the Z index -1. And let's copy and paste code. Ooh, oops. All right, let's try this again. Copy and paste. If they press 2, instead we will move it up in the Z order. Now let's go ahead and run that. So there's our normal world, and right now it might not be 2, but we'll go with the value. We'll say the background is 0, the king is 1, the ace is 2. Now let's go ahead and hit 1. Actually, that's going to bring it down by 1, and then we're going to hit 1 again, and now it's Z order. So what we're doing is we've just moved it on the Z ordering behind, and then now we moved it forward. See what I'm doing here? Now, the way this works, and this is one of those key concepts going way back to the beginning of the tutorial, I told you that LibGDX is actually 3D. It's using 2 coordinates, so 99% of the time you just deal with X and Y coordinates. However, all these things are actually being drawn in 3D, and each of these graphics is being layered on top of each other. So you can think of it like sitting on a scrapbooking table or whatever, and you put down something, and then you put down something on top of it, and something on top of it, and something on top of it. That ordering, that depth, is the Z coordinate at work. You've got this 3D world, and it's you know, there's no perspective correction, so it's all being drawn straight out in front of you, but the Z depth is what determines what is on top of each other, and setting this Z index then determines what is layered on top of what. So that's pretty key concept there. The only other thing to be aware of, and I'm not going to cover it in this particular tutorial, but if you do get into this situation, Gamefromscratch.com's written tutorials have a write-up on this. It's if you inherit your own actor or your own group, and you are going to be doing hit testing on them. Like sometimes, in this case, the default hit test, when you actually do this, when I call where'd it go? When I call hit, Stage is actually iterating through all of the things in it, and it's checking. It's just like there's a draw and an act call on all your actors. There's also a hit call, and if you inherit your own actor, and you can override that that hit evaluation, and by default, what that hit is doing. It's just going to call set bounds. And remember earlier on I said calling set bounds to set the dimensions of your actor is very important. This is part of the reason why. But by default, all it does is just a set bounds and sees if the coordinates are within that value. If this x and this y coordinate that you pass in are within the bounds of the actor, then it returns true. Otherwise, it returns false, and it goes on to the next in the scene, and the next in the scene, and the next in the scene, and so on and so forth. However, if you have, say, a circle, you can override the hit, and this is exactly what I did on Gamefromscratch, so you can go ahead and look at that example there. You can have the logic instead use the radius around the point, and so it better fits what you've got. Or you could do... and internally, you could have a polygon mesh that's like the boundary of your coordinates or whatever. Hit can be overridden in any actor. Just make sure that you return out true if there is a hit and false if there is not, and that will cause it to keep iterating through. Again, though, that set bounds call, if you're inheriting your own class, is critical. Image is calling it for us, so we haven't had to do it here. But earlier on, when we made a sprite ourselves and provided our own graphic, that set bounds call is what makes the default hit work. And if you inherit hit, you can do whatever you want with it. So you could even have it so that you could have hit but transparent. So then the object updates itself, but it goes ahead and returns false, so then it keeps checking things. It'd be a good way to do layering stuff on top, that you want to have notification that it was clicked, but you don't necessarily want to stop it from talking to things that are further down in the Z order. So those are two very different concepts, but very important to creating a game in Scene2D. So the first one is grouping. You can add as many actors as you wish to a group. Group can be thought of as an entity, like a helicopter made up of different parts, or it can be even your data container for levels. So you could have the stage being your game, and then groups being each level. Or we'll see later on, a group can actually be UI components, etc. We'll cover using Scene2D for UI very shortly. But grouping is a very key concept. It's for, obviously, grouping things together, and when you manipulate the entire group, all of the children are affected. However, as you saw, you can also grab the individual children and manipulate them. You can use the children, you can go through, use an iterator, you can loop through them from the first and then grab the next and go through accordingly, or you can grab them by index, or as you saw, you can tag them with a name, which is very powerful. Gives you a way to easily assess things that you've added in, so you could add a thing as the player and easily retrieve it from anywhere using that key. So naming actors is quite a powerful little feature, something you should definitely be aware of. And then finally, we covered on hit testing. Hit testing is simply a matter of determining if something somewhere was there at the location you specified. So in this case, we use the mouse coordinates being passed in, and we translate those back to screen coordinates. We do a hit test on. If there is a hit, it returns the actor that was hit. Once again, and most importantly, it returns the first one that is hit. If there's no weird inheritance or anything, you haven't overridden anything, that will always be the default behavior. So if you want to change that, you will have to do the work yourself. Now, that's pretty much it, I think. So I hope you enjoyed that. Stay tuned for the next part. Thank you very much. Bye.